This video is going to show you the elimination method for linear systems, and it is the third and final method that you will have to know. Most students find this one to be the easiest and the most efficient, so they like to refer back to this one whenever they get the choice to. So again, just like with all the other methods, I'm going to give you the steps to do the elimination method, and then from there we will go through and practice several examples together. Okay? These steps are not going to make sense to you because you don't know the flow of how the work actually goes together, but write the words down and write the steps down, and then I will talk you through in the examples how these steps work out. All right, for number one, or step one, you are going to need to arrange the equations with like terms in columns. So basically what that is saying is that your x needs to be stacked over top of your x, your y over top of your y, etc. Right? It's got to be lined up in columns. Okay? The second step is where you are going to need to multiply one or both equations by a number to get coefficients that are opposites. For one of the variables. This is where the elimination will actually occur, is in that step. Right? Once you get through with step two, step three is going to have you add the equations from step two. Combining like terms will eliminate one variable. You will need to solve for the other variable. And this is where you will get half of your answer. Right? So after step three, you can write your ordered pair with half of it filled in. Okay? For step four, you will need to substitute the value from step three into either one. It does not matter which one. That's the beauty of this method, is you can use either one, unlike substitution, to either one of the original equations. And solve for the other variable. So this will give you the other half to your ordered pair, which is your answer. Right? And then step five, just like I've mentioned in all the other methods, is your optional check. So you can choose to check your answer and see if it works or not. All right, so the rest of the notes are going to be different examples, and I'm going to try and show you a nice variety so that when you see one of these, you'll know exactly what to do and how to deal with it in a way that gets you an answer quickly, and that many of you find this to be your favorite method. All right, so the first example, or the first system that I'm going to have you dealing with, is 4x plus 3y equals 16, and 2x minus 3y equals 8. All right, step one says to make sure that they're lined up in columns, x over x, y over y, constant over constant. This one is lined up, so there's no step one to do. All right, step two is to multiply one or both equations so that the coefficients in front of one of the letters are opposites. Well, if you look at your x coefficients, you have a positive 4 and a positive 2. Those are not opposites. But if you look at your y's, you have a positive 3 and a negative 3. Those are already opposites of each other, so you don't need to change any of the equations. This system is ready to go in terms of step 3. So now you're going to add the equations. together to combine and make one equation to get your value. Your 3y and your negative 3y are going to eliminate. That's where the name comes from for this method. 4x plus 2x will give you 6x. 16 plus 8 will give you 24. You're going to divide by 6, and very quickly you end up with half of your answer. The x value to this one is going to be 4. So when you go to write your solution, you will have a 4 in the x spot of your ordered pair. Now, to get your y value, you can use either one of the original equations, and you're going to plug the x in as 4. All right. I typically try to go for the numbers that have fewer negatives and lower numbers to make it easier. So I'm going to take this 4, and I'm going to plug it into the x spot of the first equation. You can use the x of the second equation. It all comes out the same. So I'm going to have 4 times 4 plus 3y equals 16. And now I have to solve it for y. So I've got 16 plus 3y equals 16. I'm going to subtract 16 from both sides. And that gives me 3y equals 0. Divide by 3, and I get y equals 0. So now that I have a y value, I have the other half to my answer. So the answer to this one is 4, 0. All right, let's do another one that practices with this. Notice it takes up less space on your paper, which is what students like the most, in addition to it being pretty simple to understand. All right, so if I give you the values or the equations of m plus 3n equals 2 and negative m plus 2n equals 3, right? Again, make sure they're stacked up, which they are. So I'm looking next to find coefficients that are opposites of each other. For the m's, I have a positive one and a negative one, so that's already ready to go. I don't need to change anything. So now I'm going to combine by adding vertically the equations. My m minus m is going to eliminate. 3n plus 2n is going to give me 5n. 2 plus 3 is 5. Divide both sides by 5, and you get n equals 1. Remember, when you go to write your ordered pair, you have to keep your letters alphabetical. N comes after m, so the 1 is going to go in the second spot. Okay, so make sure you know your alphabet really well. Right, now that I have my n value, I'm going to take the value of 1, and I'm going to go back to either equation and try and figure out what m is. Because the m in the first equation is positive, I'm going to stick this one into the first equation, and it'll give me an answer pretty quickly. So I have m plus 3 times 1 equals 2, which is m plus 3 equals 2. Subtract the 3, and I get m equals negative 1. So my m value is negative 1. So the answer to this ordered pair is negative 1, positive 1. All right, for the next one, we're going to shake it up a little bit and give you a little bit more variety here. The equations are not going to be ready to eliminate. So you're going to have to do some changes to make that happen. Okay. Your originals are going to be 3x plus 5y equals 6 and negative 4x plus 2y equals 5. All right. They are stacked up in columns, so that's not an issue. If you go to look for coefficients that are opposites, none of them are ready to eliminate right off the bat. But if you look at your signs, for the x, you have a positive 3 and a negative 4. Your signs are already opposites. You just have to work on changing the numbers in front of the x to be coefficients that'll cancel. Right? So what I'm looking for is something to multiply the top equation by and the bottom equation by 2 separate numbers so that I get a number that they can both cancel out to. For 3 and 4, the best number to go to is 12 because that's a common factor of them. Right? So if I want to get from positive 3 to 12, I'm going to have to multiply the top equation by 4. That gives me 12x plus 20y, remember everything has to multiply, equals 24. Okay. For the bottom, I don't want to multiply by 4. I want to multiply by a number that will give me a negative 12 for the x so that I can get it to eliminate. And the way that one is going to work is to multiply by 3. So 3 times negative 4 will give me negative 12x, and then I'll get plus 6y equals 15. Okay, now that I've done that, you should very easily be able to see that you have coefficients that can cancel and eliminate. And so your problem can continue just like normal. But you had to change those first original equations to get this to happen. It doesn't just happen on its own automatically. Now your 12x's can be canceled. 20y plus 6y is 26y equals 24 plus 15 is 39. Okay, then you want to take and divide by 26. Okay, and you do need to reduce. 13 can actually go into both of these, and that'll give you the fraction of 3 over 2. right? So when you go to write your final answer, in the second spot, you will have 3 over 2. Okay, but now we've got to figure out the x value, and here's where you want to go back to the very first original equations you have, right? I'm looking at a place to stick 3 over 2. Well, if you look at your two choices, you have 5y and 2y as your choices. If I'm going to stick in a fraction 3 over 2, I'm going to stick it in the place where my fraction is going to go away if I can make it go away. So I'm going to choose the second equation to plug that number into. So this would be negative 4x plus 2 times 3 over 2 equals 5. Right? And you'll notice that this 2 and that 2 on the bottom of the fraction will cancel each other out. So now I've got negative 4x plus 3 equals 5. Subtract your 3. You have negative 4x equals 2. Divide by negative 4. And 2 over negative 4 will reduce to negative 1/2. So when you go to your ordered pair, negative 1/2 will be the value in front. So even though it came out with fractions in both places, you could get the fractions in a way that wasn't too extreme. Right, so let's do some more to show you other ones that can possibly happen. Right, the next thing I want to show you is one where we still have to focus on this whole changing bit so that you can practice getting them ready to eliminate. So 2g minus 3h equals 0 and 3g minus 2h equals 5. Right? So they're stacked up and ready to go. Now I want to look at my g's and h's and see what's going on. None of them are opposite signs, which means I'm going to have to work around that just a little bit. Right? But I'm going to deal more with the positives than the negatives. Right? So I'm going to focus on the g's first. And with it being a 3 and a 2, I'm going to have to make my magic number to get to be a 6. Right? So in order to get from 2g to 6g, I want to multiply by 3. So that gives me 6g minus 9h equals 0. Because I have to multiply everybody by 3. Now for the bottom, I want the bottom to be a negative 6g so that my g's will cancel off. So in order to get to negative 6, I have to multiply everybody by negative 2. That will create a negative 6g plus 4h equals negative 10. And now I can eliminate the g's and continue with my problem. Negative 9h plus 4h is negative 5h. 0 minus 10 is negative 5. I'm sorry, negative 10. Get ahead of myself here. You're going to divide both sides by negative 5, and you get h equals positive 2. Right? Now in terms of the alphabet, g comes before h, so when you're setting up your ordered pair, the 2 has to go in the h spot. Now that you have a value for h, you can go into any equation and find the g. I'm going to stick it in the first one, just because I like seeing the number 0. So I'm going to stick this 2 right here for that h, and I'm going to solve it for g. So I've got 2g minus 3 times 2 equals 0. Okay, 3 times 2 will give you 6, so 2g minus 6 equals 0. Now add your 6 to both sides. You have 2g equals 6. Divide by 2, and this will give you a value for g equals 3. So in your ordered pair, the answer becomes 3, 2. All right, we have one more example we're going to do together, and it's perhaps one of the trickier ones to do because it involves step 1. Okay, so let's see if we can get you to understand what's going on here. All right, for this one, is this number 4 or number 5? Oh, no, this is number 5, sorry. All right, for this one, you're going to have to rearrange the values to make them line up. Here's what I mean. You have 3x plus 2y equals 8. And you have 2y equals 12 minus 5x. Notice how nothing is lined up in the right way that it's supposed to be. It has to be x over x, y over y, equal over equal, number over number. None of that's ready to go. So you have to make a decision of which one you want to move. If you want to make the top one look like the bottom one, you can, or if you want to make the bottom one look like the top one. But you can only make one look like the other one. You can't move them both around. Otherwise, you're going to get nowhere. So because the first one looks like standard form, and I know you guys are comfortable with the way it looks, I'm going to take the second one and make it look like the first one. Right? So I'm going to take the second one and really make it look like standard form, and then I'll have it lined up. So I'm going to rewrite my 3x plus 2y equals 8 off to the side. But in order to make my second equation look like that, I'm going to have to add this 5x over. So now I'm going to have 5x plus 2y equals 12. That's going to become my new system. Right, now I have to look that they're stacked up. I have to look for coefficients that can eliminate. I see +3, +5, and I see a +2 and a +2, which those are almost a +2 and a -2. I can take one equation and change it and get a second equation that will make the 2y go away. And it's very easy to do that. If you take either one, it doesn't matter, I'm going to take the top one, and if you multiply it by -1, you're going to end up with -3x minus 2y equals -8. And then your other one is +5x plus 2y equals 12. Now, if you look at this, you have your y's that are ready to eliminate, and you can continue on with the regular process. -3x plus 5x is going to be 2x equals -8 plus 12 is 4. Divide by 2, and x equals 2. Okay, so now that you have your answer, half of it is going to be a 2. You want to go back and plug this in to find the other half. When you go back to plug it in, you want to go back to your original equations and put that x in as a 2. So if I'm looking at it, it looks like the second one would be a lot easier to do because I can take this 2 and go put it in right there. And here's what it's going to look like. I'm going to have 2y equals 12 minus, make that 12 look better, 12 minus 5 times 2. Right, well, if I clean up the right-hand side, this is 12 minus 10, which is 2. So I've got 2y equals 2. I'm going to divide by 2, and I get y equals 1. So I end up with a y value of 1. So the answer is 2, 1. The trick to this one is to manipulate one of the equations so that it looks like the other one before you start the elimination process. All right, so through practicing on EduCanon and through what we do in class, hopefully you'll find that this method is one of your favorites. It is less time consuming and more efficient to use. All right, so we'll see how you guys feel about that one.